massively,
Yes,
massively
massive, yeah,
parallel
parallel
processing
process. Yeah,
architecture, right? So if it is symmetric,
yes,
you will have one node with multiple CPU cores in a node. If it is massively
yes,
parallel processing, we can have multiple nodes connected together in a cluster, and
yes,
each
yeah,
node can have multiple CPU cores, right? Yeah.
yes,
So that after that, so we discussed about Ab Initio architecture. That's right. So where we discussed about two different architecture, right? So one is the legacy architecture and the latest architecture, right?
correct.
So legacy and latest architecture. So the latest architecture based on the cooperating system version. So if the cooperating system version is greater than or equal to 2.15, yeah, that's right, 2.15.
2.14.
So there is a so till 2.14, we have to establish two connections to
Yes,
connect to the cooperating system in the EME from the GD. Starting from 2.15, they
yeah,
introduced a product called Application Hub. So we can connect to the Application Hub from the GD. Application Hub takes care of connecting to the cooperating system for running the job and EME for the version management. Right. So it is one
right,
connection to the application hub so that the application hub will take care of connecting to the cooperating system and the EME application. Right. So,
correct.
and when we discussed about this architecture, so we discussed on the difference between the run host and the processing host. Right. So run host and the processing host. The run host
Yeah,
is a primary server. So from the GD, so we connect to the run host only, right? So run host is the primary server where we can have the cooperating system and EME installed on the run host server. Processing processing host is a secondary server, so we can have cooperating system installed on the processing host for running the jobs so that we can improve the performance by utilizing the resources, CPU and memory of for the processing computer as well, along with the run host. So we can make use of the system resources of the processing computer as well. For improving the performance, we can have the processing host as well.
yes,
So after that, so we discussed on so what happens when the graph runs, right? So what happens when the graph runs? So what are all the different processes which gets created when the job gets executed from the GD? So where we discussed about
launcher,
launcher, launcher, then
agent,
agent
and
and
components.
component process. Right, so these are all the different processes that gets created whenever we deploy the job as a deployed script to the co-op installed machine. So when we deploy the job to the run host, so first process which will get created is the launcher. So the launcher will create the agents on the run host as well as on the processing computer. Agent will create the component process based on the number of components that we are using or number of partitions that we are having. So it will create that many number of component processes.
Yes,
Right. So where we discussed on one example with one example to see how many launcher agent and component will get created, and also there are two case study, right? So where when we are extracting the data from a table to a file, how many number of process will get created, right? So we have run host and the processing computer. So when you have run host and processing computer, so for this first use case, let's take the first use case. So for this first use case, so how many number of launcher will get created?
launcher will be always one.
That's right. So launcher is one. How about agent?
Agent, so we have discussed when the two processes or the two multi layers or the files we have created on the on the run host, and two were created on the processing. So
That's
I think
correct.
two agent, yeah,
That's right. That's right. Two agents. How about the
and
component process?
let's say we have a four way. So one component table PBKS 1
That's
till
right.
PBKS, and
That's right.
it's 4 and 4.
That's correct.
So
So it is
8,
4 into
10.
4. Yeah, it is 4 into 4, right? So
Yes,
it is number of components into number of partitions,
yes, yes.
right? Now coming to this second use case. So the second use case is more of SQL Server table unload. So you're going to unload data from the SQL Server. Okay, so the SQL
Mm.
Server is installed on a gateway
Uh,
server. We have a
Before coming,
gateway. Yeah. Uh-huh.
okay, 8 and 10. So, I would like to understand. So, what the highest number of the the processes we have it. That's what we have it at the component.
No, I didn't get that question. What is the question?
How the only the 16 number will come over here? 16
Correct. For this
component process.
graph, yeah, for this graph, we will have 16 component process gets created. For this job, it is 16 component processes.
16 for,
So the 16,
so,
8,
yes.
8 processes in run host, 8 in run host, and 8 in processing host.
Oh, okay, okay. Total, you were
Yeah,
saying.
total 16. Yeah, that's
Okay.
right. Here?
Yeah, good, clear,
Okay.
clear.
Yeah. So now moving on to the second use case, right? So the second use case, so here you have one another server called a gateway server, which is a Windows server. So on the Windows server, we have the SQL Server database installed. So for connecting to the SQL Server database, so we have to connect through this great gateway server. So from the run host, we have to connect to this gateway server for unloading the data from the SQL Server database table. So if this is the case, we'll see on how many number of launcher. So what is the number of launcher process?
Same as the above. One and agent
Right,
will be
launcher
same.
is always, yeah, agent is going to be 3. That's right. So here we have a
Okay,
gateway server, right? So we have a gateway server. So on the
okay. On the
gateway server also
Windows,
we have,
okay.
yeah, that's right. So on the gateway server you have one agent to control the component process which gets created in the gateway server. That's right. So for the component process, we will just separate it out, okay, so that it will be easy. Okay, so we'll just see for the gateway server, run host, and processing host. Right. So for the gate in the gateway server, how many number of jobs, how many number of process will get created?
Single,
Yes,
I
that's right.
think.
Run host,
Most will be one, two plus one, two, and then I think same as above.
that's right. So it is right 4 into 2 here. So here also it is going to be 4 into, so here it is 8, and here it is going to be,
Uh, how
yeah,
the 8 number is coming, I'm not getting, because see, for a reformat and output file, okay, it
yeah, yeah,
will
yeah, yeah,
come.
yeah. You are right. You are right. I think in the first one also it requires a change. That's right. So here input table, it is a serial way. It is one process. For PBKS, it is going to run in a multi-way. So here it is one plus reformat will run in multi-way. One plus then output file will be a multi-file. So here it is like into 2. So this is going to be 1 for input table plus 3 into 2. It is 3 into 2, which is 6, 1 plus 6, 7 process. 7 process in run host. So the same way you will have 7 process in the processing computer.
Yeah. Even layout for the PBKs is also a serial.
No, it
After
is
PB, no,
no. If no, no, it has to be multi-file. If it is serial, then how the data will get partitioned and stored in the corresponding data directories? It has to be
no,
MFS.
no, the components followed by the the partition component will get changed, right? Till the PBKs, if we have before the PBKs, if we have the serial, and the
Hmm.
PBKs will have the serial layout only.
No, no, no. It always get it from the right side neighboring component. So it will get the layout from the right side component. So the reformat will get it from the output file, which is a
Okay,
multi-file,
okay,
which is a multi-file. Reformat will get it from the right side component, which is a multi-file. So this PBKS will get the layout from this reformat component. So since the reformat component is having a multi-file layout, so it will just convert the serial flow into multiple partitions. It will store the data in 4 different data directories.
okay, sure.
Only
Okay,
the
okay, got
input
it.
table is serial. Yeah, only the input table is serial. So this PBKS, it should have MFS layout. So it will get the MFS layout from the neighboring component, which from the right side neighboring component, which is the reformat. So the reformat is having an MFS layout. So this PBKS will also run in the MFS layout.
Okay,
Okay, yeah, fine then. So now the same is applicable here as well. So the same is applicable here as well. So here also you will have the same set of processes which gets created in the run host as well as in the processing computer. So 14 plus 1, 14 plus 1, which is 15 processes here. So here as a total, you will have 14 processes. Okay,
yes.
right. So with this, right? So any other questions that you have? So apart from this, do you have any other question?
Mm, usually we are also giving the multi. Just give me a minute. Huh? Sorry, sorry.
Yeah, yeah, not a problem, not a problem.
Usually we are giving the multi layout in the input table component, right? Or it
Yes,
will
we
be
can do that as well. We
or
can do that as
we will be using the AB local.
well. We can do that as well. We can do that if you want a parallel unload to happen from the source table. We can
Uh,
specify the
if
multi-file layout for the input table as
can
well.
you mind if I receive one call?
Yeah,
Actually,
yeah,
it's a
yeah,
pickup call from my driver out to
yeah,
the
yeah, yeah,
office.
yeah, yeah,
I will
yeah,
have to
yeah, yeah.
pick
Go ahead.
up. Sorry.
Yeah, yeah. Go ahead, please. Yeah, go ahead.
The input table, actually, I have, or if not today, might be some other day. Actually, I would like to understand on how that layout is being picked up when we go with the AB local, or when we use the because when we go the default it is a serial, but when we go with
That's
the
right.
AIMFS kind of a thing, then it will pick up the multi layout. So how it will pick up the multi layout, or will it be related to the partitioning in the table? That if you get it cover in one of the class, then it would be great, because I have
Sure.
more. Actually, I am not very clear. I don't have much and don't know the fundamentals actually. How it is picking up the multi layout, or whether it's based on that or not. So just need a
Okay.
clarification on that.
Okay. Okay. So for that, layout, right? So any component, right? Any component in Ab Initio will try to get the layout from the right side neighboring component. At first, it try to get the layout from the right side neighboring component. If there is no right
Okay.
side neighboring component, if there is no right side neighboring component, then it is the left side. So first preference will always be the right side neighboring component. So for the right side neighboring component, it always starts from the extreme right. So when I say extreme right, so you can see, you can take this output file. So
Mm-hmm.
for this
Correct,
output
correct.
file, so you have a multi-file layout, right? So this multi-file layout, so the next component that we have is a reformat component. This reformat will get the layout from this multi-file component, unless and otherwise you explicitly specify the layout. So if you say propagate from neighbors, the default option is propagate from neighbors, right? So when we specify the
Yes.
layout, we have different options where we can say propagate from neighbors, or you can say use another port and use another component, right? Use same as,
Mm.
where you can select
Yes.
one particular component so that it will get the layout from that particular component, or you can hard code the layout, right? So you can specify the layout by hard coding the layout. There is an option to specify the path, so you can specify the path also, right? So you can, so if you are not specifying this layout option, if you are not using this layout or same as option, by default when you say propagate from neighbors, it gets from the right side neighboring component. So this partition by key and sort, right? So this partition by key and sort can work in serial as well as multi-file. So it can work in serial as well as in the multi-file. So if you are going to use this PBKS in a serial way, okay, if you are going to use this PBKS in a serial way, so we can use that. We can use PBKS or any partition components in serial way. Whenever we use this PBKS or partition, any other partition components in a serial way, so instead of partitions, it is going to be the number of flows. So you can connect any number of flows. So say for example, so here you are connecting three flows, three output files. So you have three output files. So when you connect to the three output files, so the three output files are serial files. So here the three output files are serial files, three different files. So the partition by key and Z, what it will do is it will split the data based on the key value into three different flows. Okay, so based on the key, so it will get the hash value, and based on the hash value, it will decide to which partition or to which flow the data has to go. So based on that, it will just distribute data to the corresponding partition or partition if it is a multi-file, or a flow if it is a serial file. Okay, so we can use
Okay.
partition and departition components in a serial way as well. Whenever we are using this in a serial way, it has to be number of flows. It if it is multi-way, it is going to be the number of partitions. That is the only difference.
Okay.
Okay, so
Okay.
with respect to the multi-file multi unload, with respect to the unloading the data from a table, so we will discuss in detail. But if you want to do a parallel unload from the input table, so by default it is a serial. By default in database you have a database layout, so where you can set it as, by the default one is a serial layout. So if you want to do a parallel unload, so you have to specify the layout explicitly. So in the layout, you have to specify how many number of partitions it has to, how many number of partitions it has to create. So which means, so you have to specify the control directory location. Say you already have a multi-file system, okay? You have a multi-file system. So you have to specify the control directory location as a layout. So if you specify the control directory location as a layout, so based on the number of data partitions, it will do the parallel unloading. Okay, so that is how we have to do. Clear?
Okay. Clear, clear.
Right. Anything else? Any other questions?
Nothing.
Okay. So now moving on to the next. So we will discuss about the configuration settings, which you already know. It's a kind of a recap for the configuration settings that we have to do in Unix for running the
Yes.
co-op specific commands as well as the EME specific commands. for running the co-op and the EME specific commands. So what are all the configuration settings that we have to do it in the Unix environment? So for that, right? So before discussing on the setups, so we will see about the configuration files. Okay, there are two important configuration files in Ab Initio. So what are all the two important configuration files that we have?
I think AppRC and
Exactly,
Abinitio
that's right.
RC.
That's right. So appub RC and another one is Ab Initio RC. That's right. So the appub RC, we can find this appub RC under AB underscore application underscore hub. Within that, you can find it under the
Config.
config directory. Yeah, that's right. So Ab Initio RC. So there are two different Ab Initio RCs, right? So one is under the
Hmm.
cooperating system installed
Yes.
location. We can find this Ab Initio RC, and also we have one another RC. So where we can have the user specific Ab Initio RC under
Specific.
our
Yes.
under our home
Home
directory.
directory.
Yeah, under our home directory we can have the user specific Ab Initio RC. So first, for this AppRC, right? So this AppRC contains configuration variables about the Ab Initio products installed on run host. So when I say Ab Initio products installed on the run host, the products can be, so it can be a cooperating system, can be an EME key server, right? So then control center details, right? So whatever the Ab Initio products that we have installed on the run host, so those configurations are present under the AppRC. The Ab Initio RC, so the Ab Initio RC will have the details. So this contains configuration variables to connect to EME application and the processing computers. Okay, so your global Ab Initio, this is a global Ab Initio RC file. So this global Ab Initio RC file will have the server details. Will have only the server details, which is common for all the users under the global config file. So under the user specific config file, so this isn't user specific config file. So under this user specific config file, so this has details which are required to connect to EME and processing computer. So when we say details, so the details are nothing but username and password. So here you will have username and password. So it is with respect to each and every user, right? It differs from one user to another user. So the user specific credentials, we can store it in the user specific Ab Initio RC file. The global configurations with respect to the server name, then connectivity type to connect to the server, connection type, SSH connection type to the server. Then if there is an alias defined, so we can define the alias. So all the server related information, we can have it in the global RC file, and the user specific details, we can store it under the user specific Ab Initio RC file. Okay. So is this clear? Any questions on these two configuration files?
No.
There is one another config file which is host alias. So what is the use of this? Have you heard of this host alias file, and what is the use of this host alias file?
Who's alias? No.
Okay. So the host alias file. So for the servers, right? For the remote servers, so we can have the 3DNS thing, 3DNS or alias thing, right? So we can have alias or 3DNS names, which is like so ABC. Okay, let's say it. I'll
Yeah,
just take this example. Okay, so dev server 2
yeah,
dot abc dot com. Okay, so this is an alias. Okay, this is an alias name. So this points to the physical server name. Okay, this is going to point to the physical server name. So the physical server name can be like this, dot abc.com. This is going to be your physical server name, and this physical server name, right? So we can have the primary and secondary setup like that. So say for example, this is going to be your primary server and this is going to be your secondary server. So we can have these kind of setup, primary and the secondary servers. Okay,
okay,
so this is an alias, right? So we are going to make use of this alias. Using this alias, we are going to connect to the physical server whichever is active. So whichever the server is active, we are going to connect to that physical server. Okay. So in our Ab Initio RC, okay, so your processing host related information will be stored in the Ab Initio RC. So you say within the Ab Initio RC, so you will have the details like this. Let's say so you have AB underscore host.
right.
So you can have dev server 2, and you will have the corresponding alias name. You will have the corresponding alias name. And you will have AB underscore home at dev server 2. So you will have the pop install location. So which is going to be optiware slash ab initio slash ab initio say 4 underscore 0. This is your operating system version. And you will have AB underscore connection underscore method dev server 2, which is going to be SSH. Right. So these are all the details we need. So do we need any other details other than this server connection method, ab initio, home directory location? So other than that, do we need any other information to connect to the processing computer? We
Mm,
need username and password.
oh,
Right. So we need,
yes.
along with these details, we need the username and password. So you will have the username and password stored in your user specific ab initio file. AB username at dev server 2, which is going to be say BS12345, and we can store the encrypted password. So for encrypting the password, we can use m underscore password utility, right? So we can use m underscore password utility to encrypt the password. So here it is, AB encrypted password at dev server 2. You will have an encrypted password like this, right? So you will have an encrypted password like this. So
Mm,
now, as I said, right? So this is going to be the alias name. Okay, so this is an alias name. This is not a physical server name. Right. So we have to specify the corresponding physical server name, right? So for specifying the physical server name, we can make use of this host alias file. This host alias file will have the alias name and the corresponding physical server name. Okay. So that whenever we do an whenever we run the Ab Initio specific commands by specifying this alias name, in order to connect to the corresponding physical server, it will make use of this host alias file to get the corresponding physical server details. Okay, so is this clear? Excuse me.
uh, so we have this in the config only, ab home config,
Yeah, it is
host
a
alias.
config file. Yeah, it is a file. So we create the Ab Initio RC, right? Using the VA editor, we create the file. So the same way we can
Mhm.
create this file and then we can keep it under the config directory. So this file should be there. If we are making use of any aliases, so then for the
Okay,
we have to specify the corresponding physical server name within this file. So say for example, if there is a new alias, so say if there is a new processing host that gets added. So for making an entry, so we need to edit this file using the VA editor, and we need to make one more entry.
okay,
So there is one another server which is going to get added. So we have to. It is going to be 2060. So and this is going to be devserver3.abc.com. So this points to the new server. So whenever we are making use and whenever we are making use of an alias name, so the corresponding alias name should be added to the host alias file, alias name
okay,
and the physical server name. Okay,
okay.
right. So and the app.barc file. So this app.barc file, right? So it will have the configuration variables related to the Ab Initio products. So it will have AV underscore cooperating underscore system, which will have the details about the cooperating systems which are installed on your run host. Ab Initio 3 underscore 1 and Ab Initio 4 underscore 0. So let's say you have two cooperating systems
Mm,
installed. So you will have the corresponding details AB home, Ab Initio 3 underscore 1 and AB underscore home at Ab Initio 4 underscore 0. So for this 3 underscore 0, whatever be the location where the Ab Initio operating system is installed, so that location you will have it here. Ab Initio 3 underscore 1 and here you will have 4 underscore 0. And for EME, so you will have AB underscore EME underscore data stores. So this will have an alias name at dev EME. So and you will have AB underscore YAR underscore root. So this ABR root is nothing but the location where the EME application is installed. So for this dev EME, so it will have the corresponding location where the EME application is installed. So say let's say you have the EME application installed under this EME slash abinitio underscore 4 underscore 0. We will have this details. So likewise, you will have the details for the key servers and other ab initio products which are installed on your run host. So AB key server groups. So this AB key server groups will have the key server details. Okay, so if, say for example the key server name is like this. So you'll have this key server name, and if there is any URL, so you will have the key server URL as well. So your app.rc will have only the details which are installed on the run host, only the products which are installed on the run host. So those details are available within the app.rc. Ab Initio RC will have the details to connect to the EME application as well as the details which are required to connect to the processing computer. So those information we will have it in the Ab Initio RC. Host alias file will have the alias name and the physical server name. So if you are connecting to any of the physical servers using an alias name, so then we need to have this host alias file created with the alias and the corresponding physical server name details. So is this
mm,
clear? Any question on any of these configuration files?
no, 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 no.
Right. So
Q.
I'm just summarizing the steps. I'm just summarizing the steps that we have to perform for executing the cooperating system specific commands. So if you have to execute the cooperating system specific commands from the run host, from the Unix server, so before running the cooperating system specific commands, so we have to do some set of steps, right? So we will see what all the settings for running the cooperating system specific commands, coop system specific commands. First, you have to log into the Unix server. After logging into the Unix server, so for running the cooperating system specific command, so what is required? So what has to be set in the environment? So there is one parameter, there's one environmental variable which has to be set in the environment so that we can execute the cooperating system specific M commands for running M underscore pop commands. So there is one environmental variable, Ab Initio environmental variable that needs to be set in the environment. So what is that environmental variable?
Will be home.
Yes, that's right. So you have to set AB home to Ab Initio cooperating system installed location. So where do we set this AB home?
Mhm. Dot of profile.
Correct, that's right. So in the dot profile. Then we have to source the dot profile. So how do we source the dot profile?
Uh,
I would say source or execute the dot profile.
so we, only one time when we do
Yeah,
that,
we
or
can
when
we
we
can do
edit,
we can automate. Yeah,
when
we
we
can do
edit
that. Yeah, we can
when
do
we
that.
edit the file. Yeah, only
Exactly. When
that
we do that,
times only.
correct.
Other.
Whenever we make the changes, only that time
uh,
we have to run the dot profile. Otherwise, there is no need to run the dot profile. So it
Dot
will get
profile.
executed automatically. Right.
uh,
So software ab initio underscore 40. I mentioned it as 40, right? Underscore, okay, 4 underscore 0. So this export statement should be added to the dot profile. After adding this export statement, so for running this dot profile, so we have to use dot space dollar home slash dot profile.
yep.
Okay, so we have to execute in the current environment. Whenever we execute in the current environment,
uh,
so whatever the parameters, whatever the variables which are defined within the dot profile will be available in the current shell as well as the subshells which are created under the particular session. So whatever be the number of shells that gets created within the session, so in all the subshells we can access those variables. Whatever the variables which are defined within the dot profile, we can access those variables inside the subshells as well. So that's the
Yes.
reason we are running it with dot. We are saying dot, then we are giving the script name, right? So after this, we can run the cooperating system specific commands. So cooperating system specific commands. So for running this cooperating system commands, we can use m underscore env hyphen v to execute the co-op specific commands. And also, right, so along with this ab home, okay, along with this ab home, so this ab home should be added to one another environmental variable, one another Unix environmental variable called path. Right. So AB home is an ab initio environmental variable. So this has to be available in the Unix also, right? Unix session also. So we need to add this AB home slash bin to your path variable. So we have to set this path variable also. So where we have to specify the bin directory location where the source code for Ab Initio co-op commands resides. So that we have to set it to this path variable. So because this path variable will have those details, so it will have the other executable location delimited by colon. So we should not change the existing path value. So along with this existing path value, we are going to add this Ab Initio co-op specific executable location as well. So that whenever we run the co-op specific commands, it will get the corresponding source code from this location. It will get the source code from this location.
Okay. Yep.
Right. So this automation, right? So how this is automated? So whenever we do the changes, we have to execute this dot profile. Otherwise, this dot profile execution is not needed. It will get executed automatically. So how it is automated? Do you have an idea? So how the dot profile gets executed automatically whenever we log into the next mission? So how it gets automated?
You mean to say how it executed when we
Yeah,
log
how is
into
it?
the session?
Yeah, how is it getting executed while logging into the Unix mission?
No, no, no idea.
Okay,
To be honest.
so for that, right, we need to understand the initialization script. Okay, so for that, right, so we have a list of scripts that will get executed automatically in Unix whenever you log into the Unix system. Okay, so those
Okay.
initialization scripts are nothing but so etc slash profile. This is the first script that will get executed automatically. So this is more of a global configuration file that will get executed automatically whenever the user log into the machine. Along with that, under the home directory, so you will have the files like you will have a shell specific files. Okay, you will have a shell specific files, shell specific RC file, and you will have one another file called profile file, shell specific profile file. So let's say, so if you are working on bash, so then you will have dot bash rc, and you will have a file called dot bash underscore profile. Okay, so these are all the scripts that will get executed automatically whenever we log into the Unix machine. So this etc profile, this will get executed first. So then under the user directory, based on the default shell, these scripts will get executed automatically. So we don't have access to this etc profile, right? So this is more of a global profile file. So where the root will have access to this profile file. So we'll have access to these profiles, user specific RC and the profile files. So under this files, you will have a statement to execute this dart profile. So the execute statement, right? So if this execute statement, if it gets added to this initialization scripts, while running this initialization script, then the dart profile will also get executed. So that is how it is being executed automatically. Okay, so while logging into the Unix machine, so
Okay.
since the initialization scripts are getting executed, along with the initialization script, this dot profile will also get invoked. So because this dot profile execution will get added to the initialization script. Okay, so this will be done by your administrator whenever he creates an account, right, Unix account. During that time itself, he will add the dot profile execution to the RC file, so that whenever you log into the Unix machine, so the dot profile will also get executed automatically.
Okay.
Right. So these are all the steps that we have to follow for the cooperating system specific commands. So say if we have to run the EME specific commands, air commands. So along with this, we have to do few other steps as well. So we'll see what other steps that we have to do. So along with this AB home, so we have to set one another parameter. So one another environmental variable, which is AB underscore air underscore root. So we have to set this AB air root also. So here you have to specify export AB underscore air underscore root is equal to this. So this will be the environmental variable. So this will be the environmental variable. So here you have to specify export AB underscore air underscore root is equal to. So this will be the environmental variable. So here you have to specify export AB underscore air underscore root is equal to. So this will be the environmental variable. So here you have to specify export AB underscore air underscore root is equal to. which is the location where the EME application is installed. So here you have to specify EME, then you have to specify the EME install location. This is the location where the EME application is installed. After specifying this EME installed location, for connecting to the EME application, we need the username and password, right? So what we need is, so we need to add those details to the user specific RC file. So we have to create or edit user specific Ab Initio RC file to add credentials to connect to EME application. So before that, so you can encrypt the password using M password. Encrypt the password using M underscore password utility. So when you say M underscore password, and if you say hyphen prompt, so it will ask for the password twice. So you have to enter the password twice. So then it will give you an encrypted password. So enter password, confirm password. So it will give you the encrypted password. So we can take that encrypted password and add the encrypted password to the Ab Initio RC file. So we need to add these two things to the Ab Initio RC file. Once we are done with this, then we can execute the EME specific commands. So the EME commands RLS. So the RLS will give you the directory structure in the EME, right? So it will list down the directories which are available in the EME. So when you give RLS, so it will give you from the root directory what are all the different directories which are available under the root directory. So let's say projects, metadata, reports, repository. So whatever be the directories which are available under the root directory, all those directories will get listed when you execute this RLS. So any questions? Any questions in any of these configuration settings that we have to do?
No.
Okay, fine then. So with this, right? So now we will move on to the next one. So the next one is going to be a validate component. Okay, so we need to see about this validate component, so which is very useful component. Okay, so dynamic compare records. Have you used this dynamic compare records component before?
I've used it, but that I've never actually worked on that. Yes. I've seen it and actually run the graphs where
Okay,
we are
okay.
using this.
Where this
Yeah,
component
the
is used.
CDC
Okay,
and the STD kind of a thing.
exactly,
The
exactly.
yeah,
That's right.
yeah,
That's right. That's right. So this is mainly used to perform the change data capture by used to
yeah.
perform CDC by comparing the current day data with the previous day snapshot data. Snapshot data to identify inserts, deletes, updates, unchanged records. So we can use this component. So this is a component which is readily available for perform the change data capture process. But if you don't want to use this component, so we can go with the traditional approach. So our traditional approach is going to be there are multiple ways to do this CDC, right? So we can use two join component. First join based on the primary key, right? So here you can use first join based on the primary key. When you do the join based on the primary key, So then you will get uh, the from the unused zero. So let's say your input port 0 is going to be your current and input port 1 is going to be your previous. So let's say you have in 0 as current, in 1 as previous. So unused 0 will have the new records. Unused 1 will have the deletes. So output port will have the updates plus unchanged. Now we have to separate this updates plus unchanged. So for separating this updates plus unchanged, so we do another join. So this is one approach. Okay, there are multiple approach. This is one approach. We can use a join based on the primary key plus all the updatable columns. So say you have a customer file, so you can specify customer ID, customer pin code.
Here
Yeah,
we all the fields will come.
correct. All the fields that can be updated. So when you specify all the fields which can be updated, so here from the output port
Hmm.
and change records from the
And,
unused zero,
and zero. Yeah.
yeah, it will have the updates. Right. So this is one approach. Right. So this is one approach. This is approach one, and approach two is going to be we can use join plus reformat also. So whatever the comparison which the join is doing, right, we can do it within this join component itself, first join component itself. So join based on the primary key, and we can have one column called the change the flag. So we can populate this change the flag based on comparing the in zero and the in one fields, current and the previous fields, field by field comparison. We can do field by field comparison. Based on the field by field comparison, if there is any change to any of the fields, then we can have this change flag as 1, otherwise we can have it as 0. Based on this change flag, we can have reformat with output index. So using reformat with output index, in the output index, we have to specify this change the flag. Based on this change the flag, it will send the updates and the unchanged records to the output ports. So from the output ports, we can collect it. Right. So these are all the traditional approaches. Right. So instead of going with this traditional approach, so we can directly use this dynamic compare records component. So this component itself will take care of doing all the comparisons and give the desired output. Okay, so we can find this component under the validate folder. So we can find this component under validate folder. Ports for this component. So it has new port, old port, output port, and change report. So it will have all these ports. So from the ports, we can collect the required data. So we have to define the parameters. So for the parameters, so we can specify the key. So we have to specify the key based on which it has to do the comparison. Primary key based on which it has to perform the comparison. So we can specify ignore fields as well. So what is the use of this ignore fields?
This it will not use for comparison or
Whatever the columns we don't want to be included in the comparison. So say for
okay, very good.
example, you have the create NDTM. create NDTM, create date, update date, modified date. So these columns should not be included in the comparison, right? So we can specify those columns for the ignore field so that those columns will get ignored while performing the comparison. Even if there is any change, so those columns will not get considered for the comparison. That's right. When we have a provision, to specify simple differences only. There is an option called simple differences only. So the default is true. Okay, so this default is true. So when the simple differences only option is set as true, so you will not get this unchanged records. Okay, you will not get this unchanged records. So unchanged records are nothing but so the records, so whatever the record which is there in the snapshot file, and the same record is coming in the current day file without any change, so those records are unchanged records, right? So by default in the dynamic compare records we will not get the unchanged record by default. So if we need the unchanged records, okay, if we need the unchanged record, we have to set this parameter to false. Okay, so these are all the things that we have to understand in this dynamic compare records. And along with this, right? So for the differences port, so we need to understand about this differences port. So because the other ports are straightforward, so this inserts will have the new records, deletes will have the deleted records, updates will have the records which gets updated. So there is one another port called the differences port. Okay, there is one another port called the differences port. So what this differences port will have is, so this differences port will have two vectors. Okay, one is key vector. Okay, one is key vector, and another one is key vector, and you will have the field vector. Field vector. So this key vector will have the key column details. Okay, it will have the key column details, and the field vector will have the columns which are modified. So say in the input data, so you say, let's say if you take a customer data, so in the customer data, let's say your customer city and customer pin code are changed. Okay, customer city and customer pin code are changed. You will have that the customer city and the customer pin code details available in this field vector. Your key vector will have a customer ID details. It will have the customer ID. It will have name and value. Okay, it is more of name value, key value pair. So it will have a name and the value. It will have the customer ID in the name and the value as the corresponding customer ID value. So the same name, the field vector will have the name as customer city and the corresponding value, and it will have another record. It is a record vector. Okay, it is a record vector. So it will have the customer pin code and another record. So which will have the customer pin code and the corresponding pin code value. Okay, so this looks like this. I'll show you the view data representation. So how it looks like the view data. Yeah, this is how the view data looks like. I'll just increase this. So you can see this key vector you have based on the number of key columns that we have. So here you have two key columns, account number and statement period, or the key columns. So here you have the key and the corresponding value, and you have a difference vector. So the different vector or field vector, diff vector or the field vector, so which will have the details about each columns which are modified. So here you will have, say here it is update timestamp is modified, so it will have the old value and the new value. It will have old value and the new value, and whatever be the columns which are modified, so the corresponding old and the new value, we can get it from this diff vector. Okay, so how good you are in vectors, record vectors?
Yeah, I'm aware. Yeah, I'm good with the vectors.
Okay. Okay, so we will discuss on this vectors. Okay, so that I think it would be easier for you to understand this vectors. Okay, so we will see. We'll discuss
Mm.
in the next class about the vectors and the record vectors. So post which for this dynamic compare records, right? So we'll discuss on one scenario. Okay, so the scenario is so we can use this dynamic compare records for doing the data
Mhm.
comparison, for doing the data comparison, right? So when there is a database migration, so if you are migrating from one database to another database, say for example, Sybase to Oracle. So while doing this migration activity, we need to do the comparison, right? So we need to compare the data which gets loaded in the Sybase matches with the data which gets loaded in the Oracle. So for doing this comparison, so we can make use of this dynamic compare records, and we can create an Excel. So that Excel will have the details about what are all the columns which gets modified, what is the old value and what is the new value. So for creating that Excel and sending an Excel through email. So if we have to develop a job, so we can develop a job with the help of this dynamic compare record. Okay.
Okay.
So for that, right?
Sure.
So in order to create that Excel, so you have the vector. So in the vector, you have the details. You have the column name, old value, and the previous value. So you have to flatten that data, and you need to store it in the Excel, right? So we will see how to flatten the data and store it in the Excel. So for that, we need to have an understanding on the vectors and the record vectors. So probably after having this vectors and record vectors discussion, so we will see how we can
Mhm.
do this normalize, how we can flatten this data, and how we can write it in the Excel, so that we can send the Excel. Okay, we can send the Excel to the user. So we
Sure.
can just develop one job. So that job can be used for all the tables which are involved in the migration. So for the Sybase database, if there are 100 tables, so for all these 100 tables, we can use one reusable job. That reusable job can be used for doing the comparison and creating the Excel reports. So within your Excel, you will have the inserts, updates, deletes. So within the updates, so you will have the details about the old value and the new value. So when we say old value, Sybase value, and the new value is going to be the Oracle value. So you have to
Yeah.
create one Excel with these details, and you have to send it in email. For doing this, so we will see how we can do that. So after having an understanding about the vectors and the record vectors. Okay.
Yeah.